Good morning. Welcome to our presentation. My name is Yaşar Karadili. I am a team manager in Turkcell company. Turkcell is a GSM mobile company. I am working in the CRM development, software development department. My friend's name is Övünç Bozcan. Övünç Bozcan is a senior developer. Here is our agenda. At the first, we will general information about Turkcell and Turkcell IT environment. Next, we will make introduction, wallet framework and CPCM. CPCM is Central Product Catalog Management, our in-house development software. Later, we will talk about the internal structure of wallet framework. Wallet framework like how we use the Java Concurrency API and Oracle Coherence in our structure. Finally, we will show some screenshot of wallet administration console and what we get so far. We will end our presentation with questions and answer section. Turkcell has been operating in 9 countries, especially in Turkey. There is a 35 million subscriber in Turkey and 65 million subscriber in the region. Turkcell is listed on New York Stock Exchange and Istanbul Stock Exchange. The company creates employment for more than 50,000 people in Turkey, directly or indirectly. The one and only Turkish company listed on the New York Exchange. Turkcell complies with European and United States regulation. The company massive tax contribution to the Turkish government. Turkcell has social responsibility project on education, culture, and sports. After giving general information about the Turkcell, we can move to the Turkcell IT environment. Turkcell IT adopted 5 strategies in this year. First strategy is simplicity. Simple user interface, simple architecture, and simple infrastructures, meaning that simple is the best. Second is productivity. Measure and increase the productivity, such as test automations and code once used many times. Third is best place to work for employers. Fourth is strategies is quality. Increase the quality software development life cycle. Fifth strategy is innovation with customer. Innovative services that will add value to the lives of our customers. We can look to Java technologies in Turkcell IT department. The Java technologies are Servlet, Java Server Page, Enterprise Java Bean, Java Messaging System, Hibernate, Spring, Java Server Face, Prime Faces, and Oracle Coherence. Turkcell operation have 550 Unix host machines, and there are approximately 400 Oracle Weblogic server. Turkcell has developed in-house enterprise applications in domains such as self-services, CRM, Blink, Campaign, and mobile, etc. For example, in self-service domain, there are applications like SMS, USSD, individual and corporate internet branch. CRM dealer domain, Turkcell extranet applications. There are totally 1,050 employees work in Turkcell IT department. Yes, so far we talked about the Turkcell and Turkcell IT environment. Now we will explain what do we mean by the validation, and what do we mean, what is the catalog? What do we mean by validation? As a first, product and services have certain business rules associated with them. These rules decided whether the product can be offered to the subscriber or the product can be activated. There is a penalty in the activation, etc. Validation is execution of one of these business rules. To give more specific example, we can look at the example like that. Is the subscriber in blacklist? Is the subscriber member of a certain customer segment? Does the subscriber have unpaid blink? And does the subscriber change its phone number? After explaining the validation concept, now we want to give information about the valid framework. Valid framework is basically a rule execution engine. It is based on a central product and services catalog. We will explain the catalog on the ongoing slides. It acts as a unified and standard validation repository. By building the framework, we set a basic for every validation as standard form and accumulate new edit validation in unified repository. Validation in repository are parametric and reusable. You can define a validation once and use many times. The framework supports parallel execution of the rules. It is purely parametric to determine the execution strategy. You can define the rule execution as serial or parallel from valid framework administration console. Yes, we can look at this diagram. This diagram shows generally relation between the validations and applications. We can look at application 1 used validation 1 through the validation 4, and validation 2 is used by application 1, application 2, and application 3, like that. Validation 8 is used used by application 3 and application 4. Application 5 is used validation 6 and 12, which are combined as validations 10. It is used in the application 4. This is our general enterprise applications. The slide shows that same validations are developed by different developers, different methods, and different applications. We continue the same diagram. In general application, validation code is not reused because there is no validation repository. Same validation codes are repeated in different applications. When you need to change repeated validation, you will change the load one more than applications. So your development and test cost increase. For example, in this diagram, when you change the application 2, you need to develop and testing application 1, application 2, and application 3. In generally, you can see that validation is executed in the program, in the software, in serial, like serial. So you spend the longer times. In our applications, especially CRM and self-service application, we make some code sampling. We see that same validations are used more than once times. For example, blacklist validation is the customer in blacklist validation. Shared is 15 applications. is the campaign take the customer, the validation is shared 57 applications. And then we making this code sampling, we asked the question ourselves. First question is, how many applications does share the same validation? We see that I give the sampling about this one. There's a same validation used one more than applications and sometimes 57 times, 19 times, 38 times. We asked the second question ourselves, what is the percent of the validation source code in all applications code? In our sampling, we see that validation source code are 25% of codes of the all application source code. And then there's another questions. What is the development cost of validation in all software development cost? In our sampling is that 20% of whole development process. Yes, well, so far we look at the classical applications and classical validations and application relations now. Now we will show the general concept of validation frameworks. There's you remember in the telecom applications, there's two main processes. One is number change, other is SIM card change. They are in this diagram have four validation is same. Validation framework take this validations and put it the validation repository. This diagram shows the general concept of our validation framework concept. This diagram shows a general architecture of valid framework. Client applications, our client applications like dealer applications, self-service, SMS, called the valid common layer as EJB API layer. Valid framework caches all execution rule before and execute the rule in parallel depending on your descriptions. The rule repository and valid repository in here, our catalog in here, and you can make the validation like in parallel. It depends on your definition. You can manage the valid rule execution engine with valid administration console. You can see that valid administration console. You can define it. Until now, we have spoken about the validations and validation framework. After this slide, we will speak about the catalog. What is the catalog? What do we mean by the catalog? What is in the catalog? Modules of catalog, etc. We will talk about these topics in detail ongoing slides. Well, when you go to any market, for example, you are handed a booklet about company product and services. What do we mean by catalog is actually the same. Catalog is complete list of product definition and specification. The product in any market are pretty much straightforward, sofa, table, electronic equipment like that. But the range in the telecommunication is widespread. So we define the product as any services or benefit that is offered to the customer or subscriber. Turkcell have developed in-house catalog, CPCM-Central Product Catalog Management. It is a central multi-domain product catalog. Validation framework is a validation repository. But there is still need for cataloging the product. Services and their business rules, client application should be aware of product, services, and the business rules associated with them. Well, CPCM, Central Product Catalog Management, has 6 modules. They are catalog, price, rule, resource, profile, and version management. Validation framework uses rule management in the CPCM. Generally, after explaining the catalog, now we can move to the rule management. Rule management is composed of several entity structures. The atomic piece of it is criteria. Criteria encapsulate the atomic business rules. Rule structure is composed of criteria and their logical and or not combination. Business rules can be associated with offer, product catalog, etc. Every company have different channel, like self-service channel or dealer channel. Different channel can have different business rules for the same product. Maybe you want to give some product from your SMS channel or internet channel, but you do not want to offer the subscriber, your subscriber, your dealer channel. You can spread this one in the catalog definition. Business rules can be shared among different products. They can often be reused. Validation framework is designed as rule execution engine of the CPCM. CPCM meaning Central Product Catalog Management. Valid framework contains the necessary data retrieval services to execute the business rule. It executes the business rules based on the data gathered from the data retrieval services and the operator and operand data read from the CPCM. Valid framework executes the business rules in serial or parallel manner. It executes the business rules in priority-based fashion. Validation framework abstract the CPCM rule management module from the client applications and its data model from the client applications. In this part, how is a simple validation is executed? We can look at client sent request to the to rule execution. Valid creates the business rules tree. In this example, our subscriber want to change her its tariff, its phone number, its MSSN tariff. Customer wants to change the tariff as a super tariff. There is 4 pre-request conditions to change the tariff. They are the phone number MSSN must be postpaid. Customer must be individual. Customer status must be activate. Customer current tariff code must be 273. In the previous slide, there are 4 pre-request conditions to change the tariff. Tariff code validation is one of them, which is atomic business rules. We are explaining deeply in this slide. A simple validation consists of two steps. One is data retrieval step. Backend system calls are integrated into flow like in the structure, like the structure. Comparison step, actual rule execution step. Write operand and the operator data is taken from the central product catalog management. Left operand is obtained in the first step. Comparison output is returned true or false. Yes, we will continue the valid framework internal structure technologies. My friends, Övünç Bolcan, continue the presentation.
Okay. Hi, welcome again. Well, before diving into the internal details, I want to summarize the execution step as follows. As you can figure out from the previous slides, a request is actually processed in two steps. First step is business rule tree extraction step. Well, we didn't give much detail about our catalog data structure, but please keep in mind that it's very complicated and it's very hierarchical. For example, an offer is generated from a product, and a product is created from a catalog, and a product may have several groups, product groups, and products may have technical components, technical elements attached to it, and other resources attached to it, notifications, etc. This goes on and on. There are about 40 different entity types in CPCM, and they are all entangled with each other somehow. Every entity in the catalog may have a rule attached to it. So, business rule tree extraction step requires a deep scan of all this hierarchical data model. So, it should be as fast as possible. And we use Oracle Coherence to use the already extracted rule trees. Second step is the actual execution step of the rule trees extracted previously on the first step. Performance and system resource utilization is of high importance in this step. This step is majorly constituted of backend system calls, data retrieval steps. These are actually they are the major bottleneck of our system, because we need to make these calls, these backend system calls, concurrent, and we need to cache these calls in order to have better performance. So we use Java Concurrency API to make them concurrent, and we use Oracle Coherence to cache the results. Well, these are technologies we used. I'll give you more details about them in the ongoing slides. I'll briefly mention why we choose them or how we use them in the next slides. Well, Spring Framework constitutes the infrastructure of our application. We gathered the logically related operations in Spring services. For example, we create a cache server to handle cache operations and execution services. We have logging services or repository services. So, moreover, we want to focus on mainly our algorithms. Spring enables us to write POJO services, so we don't deal with the cumbersome stuff like object creation, wiring, etc. And our codes are much simpler. In addition, we want to construct our application with a test-driven approach. With the dependency injection, stubbing and mocking services is quite easy. We also try to ensure code coverage in testing with EMMA. This is not actually related to Spring, but it's related to unit testing, so I put it in here. We also use EMMA. So one of our primary objectives when we start the project was to build a validation repository. and to dynamically modify the business rules. In order to do so, we have to write validations atomically and let the application do all the configuration, wiring, etc. So we have a complicated structure stored in our configuration database system, and Hibernate has helped us to map these complex and detailed structures to database without even writing JDBC. So CRUD operations are very easy to implement, and our development effort is quite reduced with the help of Hibernate. Well, in the previous slides, I mentioned about the parallel execution. This slide and the next two slides will deal about the concept in more detail. We parallelized the rule tree execution and rule tree execution step and service call flows. We implemented the thread factory interfaces and used executors with cache thread pools. As I mentioned before, the main bottleneck in the execution step is the backend system calls. The performance problems in these systems instantly affecting our system. For example, when we first deploy our project in the production environment, one of our backend systems has not been responding our requests, so our servers eventually crash, and we need to put some timeout mechanism in our backend system calls. Java Concurrency API enables us to do that in an easy way. Well, also another thing we take into consideration is asynchronous logging. We are building a validation system, rule execution engine, and logging of the requests, responses, and validation outputs is of great importance, because you always have objections to what you execute, what you have in your comparisons. And we have to lead the operation team and other development teams as fast as possible and in a proper manner. So we build a detailed logging mechanism, but we have such an heavy system. We should also look out for performance. So we implemented our logging system is in asynchronous way, and we use Java Concurrency API for that. Well, let's look at the detail of the parallelization scheme in rule tree execution. You remember our traditional example in the previous slides, from our previous slides. It has 4 business rules ended together: payment type validation, customer type validation, account status validation, and tariff code validation. If one validation takes 1 second to finish, then it takes 4 seconds to execute all 4 validations in serial. So we do not want that. However, if you executed them in parallel, it would take roughly 1 second to be completed with the consolidation overhead. Another thing to notice is that you won't need to wait the whole execution. If an ANDed validation turns out false, or an OR validation turns out true, you can end the execution, because no matter what the results of other validations are, false in AND and true in OR will dominate the overall result. This is the short-circuited Boolean logic, and we adapted that in our rule execution. What's also parallelized is the disjoint service call flows. For example, consider the example in the slide. This is the asset limit validation example, which takes MSA and phone number as input and decides whether the customer has no more than 10 assets or not. What's done here is the counting of the assets attached to the prepaid lines and counting of the assets attached to the postpaid lines, and then summing them up together to make the comparison. As you notice, counting prepaid line assets and postpaid line assets are independent of each other. So we made these calls parallel to have better performance. So all in all, we can say that disjoint paths in the service call flows are executed in parallel. Well, we obtain remuting by using EJB3. It's a standard framework defined by Java Community Process, and is supported by all major J2E vendors. It's easy to implement, so there's no harm done in doing so. We don't have to write deployment descriptors in an XML file, or we don't have to generate extra code with other frameworks such as Xtoclet in EJB3. Moreover, Spring services can also be injected in AGB POJOs, and it's quite simple. So we choose AGB3 in a technical aspect, and well, there's a non-technical aspect also. You can ask why UGB instead of web service. The reason for that is the flexible nature of our request and response objects. One of our primary objective was to create a validation repository which serves several domains. So we have in Turkcell campaign domain and tariff management domain and other CRM domains. Every domain has a different data structure, and in order to overcome the diversity of each domain while serving with the web services, you need to set up a canonical order model which suits for each domain. And this is quite expensive task, and it's an ongoing task. Whenever you need to add a new domain to your validation repository, you need to cover its business requirements. So creating a canonical order model is an ongoing process. Well, every new domain may end up with a modification in the model. So instead, we choose to implement the request parameters as a serializable object map simply. We have common validations, and their request parameters are pretty much simple, but there are also domain-specific validations. And with serializable object maps, we can use domain-specific validations may use their own model, and we don't have to interfere with the core structure of our framework. And we also use CXF. As I said, our primary services are implemented in EJBs, but we also use CXF for some reasons, for some purposes. Well, one nice property of CXF is that we can easily integrate CXF with Spring, and we can define web service clients as Spring beans and let Spring handle the dependency injection. Well, also another purpose for using CXF is that catalog data is changing every day, and we need to refresh the cache in the case of a catalog change. So we are caching the catalog data, and we are serving our clients. But when there's a change in catalog data, often business requirements, business people requires that. So we need to implement cache callback services with CXF. That's because catalog CPCM only supports web services, and it's a contract first web service. And also we also use web services in between instance communications. I'm just skipping it for now because we will be talking about it in detail in the ongoing slides. Another essential component of our application is the implementation of Oracle Coherence. Well, CPCM contains thousands of products and hundreds of thousands of entities. So online catalog reading for each request has a major drawback. We use Oracle Coherence for caching catalog data. And also executing validations and backend system calls are expensive too for us. We use also Oracle Coherence for caching validation outputs and data retrieval services outputs. Reusage of the validation outputs among requests highly contributed to the performance of our application. So we really enjoy using Oracle Coherence. Well, what Oracle Coherence provides us is that we have faster access to data which is resided in memory, not in some other backend system. Or backend system like web services or database procedures. Moreover, it's very easy to implement Oracle Coherence. You can access data grids using simple map interfaces. And what's more is that your cache is distributed and your data is replicated among this distribution. This ensures that there won't be a single point of failure and you will gain performance in accessing cache. And also, Oracle Coherence allows us to adopt different expiration policies for data serving for different purposes. For example, our catalog data should never expire. However, certain validation outputs can expire sometime after to not to let the cache expand so much. Actually, scaling the cache is not a problem in Oracle Coherence because it supports dynamic cluster membership. You can easily add more members to the cluster in the case of an expansion. However, we do not want that unless it's a necessity. So we schedule expirations for different data types in our caches. Well, another product we use is Oracle Weblogic. We have 3 hosts serving. They are all of HP Blade series machines running on Linux Red Hat 6. Each machine has 4 CPUs, I guess it should be 4, and 24 cores in each of them. We have 12 instances running, 4 in each 3 hosts. 3 instances are dedicated to Oracle Coherence with local storage enabled. You can see these instances in darker green. And 9 instances are dedicated to application itself with local storage disabled. So we can easily restart our application instances without affecting the cache data. The major benefit of using Oracle Weblogic Server is that Oracle Weblogic Cluster offers us load balancing and failover functionality through their replica-aware steps. If one instance becomes unavailable, your request will be automatically redirected to another healthy instance. We didn't declare idempotent EJBs, but there's an option for that. Your request will be redirected unless it's processed if you define your services as idempotent. And also, Oracle Weblogic Cluster provides load balancing. This is why actually we choose EJB. If there's no load balancing, you have to combine all your applications with the clients itself in a single domain. But with load balancing, you can separate your clients and your applications, and you can serve in a proper way. Oracle Weblogic Cluster has round-robin load balancing as default, and we do not have a need to change that. So it's the same for us. But there's a drawback in this scheme. In order to communicate between instances, you should use something other than EJB. Because of the load balancing, you wouldn't know which instance will take the request. If you implement local interfaces, moreover, if you implement local interfaces, your request is automatically handled in the same JVM. So we needed to develop web services to communicate between instances. And between instance communications are used in cache refreshes, because we dedicated one single instance to deal with the catalog refreshes. It gets the request for the catalog refresh reads all the catalog data and updates in the Oracle Coherence cluster and notifies other servers to use these newly updated catalog data. So we need to implement some instance communications between the domains, between the instances. Another technology we get use of is JSF and prime faces. As you can notice, our data structure and configuration scheme is quite complicated. In order to deal with this complexity in the view layer, we need a comprehensive framework. JSF is suitable for us with view scope and partial updates. It helps us handling the complexity of our design. Moreover, with prime faces custom components, we developed the admin console quite easily. So to give some example about the admin console and its functionality, we put some screenshots on our slides. Admin console enables us to change the business rule while operating, or operation team are able to change the configuration like web service endpoints or timeout values, etc. So our administration console helps us to do that. And we also need to monitor what's in the cache. Business rules are changing every day, so in order to support operation, we need to add such functionality. Searching and filtering catalog functionalities are added to the admin console. There are certain changes that should affect at a certain time. For example, you may want a change in the catalog to be effective after midnight or after some time in the early morning. So we add some refresh scheduling screens for that. And we also, to support operation again, we designed log monitoring pages. Operation teams can query logs with these pages. Well, so far we have talked about our company, our design, and some internal details about our application. Now, to sum up and to give you more insight about what we have done so far, we will present you some numbers actually. Before giving a start to Valid, we sampled some of our source codes to examine the business rule implementations in the applications. These numbers are actually recited in previous slides. We figured out that on average 25% of the source codes are about business rules in applications. So regarding that research, one of our primary motivation was to obtain simpler source codes. With the introduction of validation repository, 25% decrease in lines of code was aimed. We measured lines of code of some services with validation framework integrated to them. So you can see the differences for different SMS services. And on the average, there was 33% decrease. Another objective that we want to accomplish is to decrease the execution times of business rules. With executing the business rules in parallel, we were expecting 30% decrease in the execution times. Integration of basic convergence project resulted in 34% decrease. Actually, there are like 25 different validations in a convergency process. So some of them were related to each other, but most of them are independent. So we make them parallel and have a gain about like 34%. And also with Valid Framework, we wanted to build a validation repository. This repository would help us reducing the development efforts on the next projects. We expected productivity and performance gain about 20% for the ongoing projects. So we used validation framework, for example, in the SMS services project. Overall project time was 28 8% decreased. Also, we expect to overcome the heavy lifting problem in telecommunication domain with the SRE project and tariff management system integration. We successfully respond 700,000 requests per day, and this complicated structure, we managed to handle that. So, to sum up.
Yes, so far we have talked about the validations, validation framework, catalog, CPCM, and their technologies. To sum up, by removing the business rules out of the flow, you will have a lighter business logic in your applications. When you construct a system with flexible and configurable business rules, you will have easily understandable and manageable structure. When you construct a validation repository, you will see that code application is avoided and change request effort are reduced. Yes, this is end of our presentation. If you want any question, we will answer it. Yes, you first.
I couldn't hear that. Can you repeat, please? We have our telecommunication domain is quite complicated, and we have business requirements changing every day. So we need to adapt something in-house developed. We looked at those approaches also, but and we also need to change the. We also need to integrate with the central catalog. Mm-hmm. So we have to adapt something like this.
In addition, there's a special product in here. We see some kind of we speak with the company Oracle's TIBCO and their catalog, but their catalog is not suitable for us. Or maybe you should to make very big customizations. In other way. We prefer develop in-house because in general the rule execution engine make the validation in serial. Generally serial. We look to some open source, but we use the Concurrency API in this here and make the validation is parallel, execute to parallel. Thank you. Please. Excuse me, is there a microphone? Is there a microphone? Yeah, okay, that's okay. Did you find any challenges with the data replication on Coherence?
No, actually we didn't have, but our company is heavily using Oracle Coherence. Yeah. Yes. Yeah. In CPCM, there are some challenges about Oracle Coherence, and they need to change their, for example, their Coherence cluster is distributed, but they need to change it to replicated to serve better. So there are some problems, there are some challenges with that in other projects, but we didn't have it.
We used as a cache for Coherence, but we use all of our enterprise applications like that Coherence, but Coherence web sites maybe we challenge.
Using Coherence web sessions, using caching web sessions for caching web sessions with Coherence is a challenging issue, and because they need to. This was about another project in our company. They need to use Oracle Coherence cluster in quite excessive numbers of instances. There are lots of members in the cluster, so it was hard to handle that much instance. That was a challenge.
We see lots of performance problems in the Coherence web in all applications, distributed layer. And we asked Oracle, but we didn't solve exactly the problem.
But this is another concept. It's not
yes
related to this.
Please.
Well, we have a dedicated team, business process team, to. If you notice that I mentioned about there are 150 tariffs in our catalog and 550 tariff options. It's about every day is changing actually. We need to. We didn't have such knowledge, but every day there's a change in catalog. We need to refresh our cache on a daily basis.
We are caching the approximately data is 20 megabyte in the Coherence each day. Yes, please. How many? Validations. That's
well,
okay.
we have over than 700 rules. So some of them are similar rules, but in total we have more than 700 rules in the catalog.
Please. Yes, but you know that using the GMS as a offline generally asynchronous, yes. But in this here, we excite using our tariff system in telecommunication. Tariff is, you know, that very important in the telecommunications, and we make this not asynchronous, just in time. And so we do it. We use the Java concurrence IP so that. Please.
You mentioned about not using other common tables.
Yes. At the same time.
Well, you are asking where.
Mm-hmm.
That's multiple rules, one parallel, or is a single rule can be split into multiple.
Yes. Well, we have several rules are running parallel, and one validation, one rule has also some BPM-like structure in it to retrieve the data from backend systems. We can also parallelize these backend system calls. And we have parallelization in two schemes. One is that the rules in the same level are parallelized. And when running a single rule, single validation, we also parallelize backend system calls if they need more than one. Yeah.
Yes.
Yeah. Well, in basic convergency, we have like 25 rules to do the operations, and most of them are ended together. So it's one super rule, and under that, it's like 20 or 18 leaf rules.
In this example, I will say that there's 25 validations. It's approximately 14 seconds. It's the time, the elapsed time. But we use the validation frameworks. It approximately 8 seconds.
In basic convergency, before introducing valid to basic convergency, we have like response times about 14 seconds. And after introducing valid, we reduce these response times about 8 seconds or 9 seconds between that. So we have like a 30% decrease in the overall response times.
But every time you can make the parallelism. It depends on the, for example, one validation is finished and other maybe start. So that sometimes all of the validations make start parallel, but sometimes serial, parallel, and then serial. You can define it in the validation administration console. This one is serial and this one is parallel, like that. Yes.
Yeah,
yes.
We have default strategy, but you are.
Yeah. Yes. What?
Yeah.
Yes.
Yeah.
Yes. At the end of.
Well, we don't have a special language for that, but we have our catalog structure. It's an in-house developed data structure, so we are using it to formulate our rules.
So almost like decision trees.
Yeah, it's actually like that.
Please.
Yeah.
Yes.
No. It's actually relation model is residing in the database. Yeah.
Yes.
This is all about CPCM. CPCM is holding the rules, so we query CPCM for the rules. They are providing us a web service to do that, and we enrich those rules with our internal data structure. So after that, we are ready to use those rules.
Please.
I had a question. So you mentioned that you're caching the validation results now, and your first application is in a mobile. It's a mobile space. So is it those validation results are typically first described?
Yeah.
So how much? I guess
Actually, we decide. We decide which validation to cache actually. For example, you may need product type to payment type change is the same for all of the customers. For example, if you have
Blacklist.
No, not blacklist. Blacklist is customer based, but for example,
so you do have rules that are configured that are
yeah.
independent of the individual subscriber.
Yeah.
Yes.
Do you match other results, or are you always going back?
Well, we have several scopes. We implement several scopes. There are times when you extract a huge rule tree, you have to use the same validation result. For example, if it's postpaid, if it's prepaid, like these, you have to use these results in several validations in a huge tree. So we are in one request. So we are saving it in request scope, but if there are also other validations that are that can be used by other customers. So we configure them and we are saving it to our cache.
And then you just let it expire.
Well, it's by default, it was 1 hour expiration policy. And it didn't change, I guess. Yeah, expand
Yes,
so
yes.
much.
Yes, there is no expire time. There's a 1 hour every time refresh the cache.
And one other question is, so maybe not the job of validation, but how do you handle, I mean, typically the backend systems are unreliable, down for hours, days.
No, not actually.
Yeah.
So how do you handle that from an overall application?
It is not related in our validation frameworks. And there's a very big persons. There's a very big departments, operations team in our company. Operations and infrastructures teams. It's approximately 300 people.
Just working for
Just
operation,
working.
maintaining machines.
What does the validation engine do when it starts when it can't get data to validate the tool? Then it starts.
Well, we just say that we could not be, we are not able to validate your request. So it's the responsibility of our client to do.
Yeah.
Yes.
Yeah.
Yes. Is there any other questions? Please.
What kind of additional comparison?
I guess it's enterprise. I'm not that sure, actually.
Okay. Thank you. If you want very detailed or maybe future questions, there's our email address. If you ask any questions, we will answer your questions. Very happy. Yes. Okay. We share it. Thank you.